Hi, welcome to the Computing There Was podcast. I am your host, Richie Bilag. Today I am speaking to Adam Liss, who started as an electrical engineer and then drifted into software engineering at the boundary of hardware and software. Hope you enjoy the conversation. Hi, welcome to the Computing There Was podcast. My name is Richie Bilag. I am your host, and today I'm speaking to my friend Adam Liss. Hi, Adam. How are you?
Good, Richie. Good to meet you. Good to see you.
Nice to see you again. I always begin with a question how you got started in computing.
I have always wanted to know how things work.
Mhm.
And it started long before I was a preteen with electronics. Life changed when I discovered how a transistor worked because I could use little bits of power to control lots of power. And then sometime I think before middle school, I bought the Radio Shack TRS-80 programming book and didn't have a computer. So I remember writing a Monopoly game on paper and then bringing that to the local Radio Shack while mom went shopping, typing it in. And it didn't work, of course, but there I guess began the journey. My first computer was an Apple II Plus, and that's pretty much where I spent my childhood.
So, how old were you? So, you were in middle school or high school by then?
I was in middle school.
Mm.
And then again, life changed when I realized that the joystick port on the Apple also had outputs, which meant I could make the Apple actually do things. That was far more exciting. Well, once you have a transistor and a phone in your room, what else would you hook things up to? So I discovered that with transistors and relays, I could take a phone off the hook. And since my folks also had a phone and it was a separate line, and I had three outputs, I think, I could take my phone off the hook if it was ringing,
Mhm.
and then take my parents' phone off the hook, use the relay to pulse dial, and then connect the two lines together. So I had my aunt call me at my house, and I was at my grandmother's house, and I picked up the phone, and she was very confused.
So, this is like early phone hacking. Interesting. So, your
Yeah.
parents let you hook up your computer to the phone line?
Well, yes, back in the days of BBSs, before there was an internet or anything, you would call up somebody else's computer and trade messages and play games and things like that.
So, you had a modem or?
Yes, I had actually by then I had gotten we called it the compact sewing machine. It was a compact portable, I think.
Mhm.
It was a state of the art Hayes internal smart modem 1200B. So
Ooh,
it was 1200 baud, about 120 characters a second.
high speed.
Yes, back then, yes.
So, this is, you were doing this stuff while you were in high school, I suppose?
Yep. In high school, we had Commodore PETs,
Mhm.
and a friend and I taught the teachers how to use them. Um, we also, of course, had the teletype that people would dial into the guidance computer and play Star Wars and just use reams and reams and reams of paper. Um, but what other escapades did we have? A friend and I wrote a computer dating service app, and we handed out paper back then to people, to other students. We sold them for, I think, $1 to raise money for the class. And basically just matched people up, right? What are you interested in? And tell us about yourself. And then we look for the matches. My senior project was using the Commodore graphics to
Mhm.
be able to write and record music score.
Oh,
And because the printer would handle those graphics, I could also print out the song. But what fun is that unless you can actually hear it? So I
right,
found out, I think, was it David who was talking about peaks and pokes last time?
right.
There were certain memory locations where you could give it a frequency and a duration and it would play that tone. Yeah, so I discovered that one of the pins on the connector in the back of the Commodore PET um, would also do this neat play a square wave musical tone thing.
Mhm.
So I was able to connect an earphone to it, so nobody could hear it except for me. Then I discovered that if I switched back and forth between two different notes fast enough, it sounded like a chord.
Wow.
So for my demonstration of my senior project, I had to play the entertainer and then print it out on the printer.
Wow. That's impressive.
It's fun. See, that's what I liked about computers back then was that there was nobody to tell you what to do. There
Right.
was nobody to tell you how to do things. There was no Google,
Right.
right? I mean, my Google was a stack of paper books on my desk with post-its on them, and you just had to figure things out. And if you had enough time, that was fun.
Right. That's right. So this is your school was in New Jersey
Yes.
because a couple of people I spoke to went to schools in New Jersey, and they're all pretty advanced stuff.
Yeah, it depends where you are. There are a couple of nice towns, and we were next to a wealthy town, and we shared the high school, so that was very nice.
Uh-huh. After high school, where did you go to college?
I went to Rutgers, majored in electrical engineering.
Oh, interesting.
Yeah, the first required course and the only engineering related course you were allowed to take freshman year was Intro to Engineering,
Hmm.
where the dean would tell us about all the different types of engineering that Rutgers had to offer. And then he went up and down the aisles and asked everybody, well, what kind of an engineer do you want to be and why?
Uh-huh.
And people would say, I want to be a mechanical engineer because my dad was a mechanical engineer.
Right.
Or I want to be a civil engineer because I like to know how to build structures.
Right.
And I said, I want to be an electrical engineer because I think it's fun. Everybody in the class laughed at me. And the dean shook his head and said, I think you're going to need a better reason than that. And, here I am, and years later,
I know.
still loving electronics. And so it was the right decision.
I think fun is a very good reason. to
It,
do.
it really is. And when I teach my kids, I teach them that it's fun. I let them figure stuff out. One of my proudest moments was when one kid said to the other, I don't know either, but don't ask dad because he'll just ask you a bunch of questions. Make you figure it out yourself. But no,
Didn't Richard Feynman wrote a book called The Pleasure of Finding Things Out,
yes, he did.
right?
Yep.
So did you take any programming courses? Oh,
Well, I say that I never really took a programming course. We were forced to take Fortran 77,
uh,
which was not much of a programming course. But I spent a whole lot of time in the computer lab on a VAX VMS system.
okay.
And that's when there wasn't, I don't think the internet was nascent. We still had to send email using like BitNet. So there were no routing tables,
Right.
right? There was no DNS. So every computer that was on the internet had to have the actual address of every other computer it wanted to talk to.
Right.
And if you wanted to talk to a computer that yours didn't know, you had to pick one that it did know and say, well, send the email there and let them figure it out.
Right.
Which is what DNS does now, except it does it automatically. So at some point, I had a list of the internet, which was several, 100 pages of IP addresses.
Did you use Usenet and Usenet groups?
Yes, definitely. Rec.humor.funny. That's when I realized that if you were a member of certain groups, you knew people who were absolutely world famous, but only to people on those groups.
Right.
And that was really interesting to me.
Yeah, and one of my early jobs, we actually convinced the bank to set up a UCP connection so we could get Usenet groups.
Nice.
So that was kind of fun.
Yeah. And of course, I spent a bunch of time. I had the compact with the modem in my dorm room, so I could dial into the school network, which was fun. They had a Linux, or I guess it was a VMS program called Talk, where a bunch of people could get on and just type to each other. And I found that after you had 3 or 4 people, one in New Brunswick, one in Newark, one in Camden, pretty much all of the Rutgers places, if everybody typed it once, it just couldn't keep up. But that was fun. So, I always say, I learned by making mistakes.
Well, that's how you learn. Yeah.
Of course. And I pretty much made all of them. So I didn't really take that. I took it was advanced computer engineering, which wasn't really a programming class, but he had us write an interpreter, I guess a math interpreter in some obscure programming language that nobody had heard of.
Mhm.
And then once we did that, we had to use that programming language to build another interpreter in yet another more obscure language. And all I really remember was that he taught us about binary coded decimal.
Okay.
And on the final exam, he had us do a long division problem in binary coded ternary.
Oh,
It's basically binary, using the binary system, but the numbers can only go from 0 to 2, which
right.
is ternary. So
Right.
it was like base 3 and base 2, and that was just cruel.
Well, for some definition of both.
On a final, it was cruel.
So when you graduated, you got your engineering degree?
Got my engineering degree, and my first job that kind of used it was at a local company that made telephone channel units, which are cards that go into the big racks in telephone offices.
Mm-hmm.
And they basically connect the telephone offices together.
Oh, okay.
And back then, a lot of people have heard of like ESS7 and things like that, different models of switch that did different things. And this company built a programmable one that could emulate any of these other ones. And they needed somebody to figure out how to test it, which was really cool because it was programming and it was using hardware. I got to use a measurement set that would generate tones and measure all kinds of words I don't remember. And I interviewed on a Friday and said, well, if you can learn C by Monday, then you can come and work for us. And I said, okay, challenge accepted. So I went out and I bought the Kernahan and Ritchie C book, which is the best technical manual I have ever read.
Right.
The first chapter takes you by the hand and tells you, if you're used to programming, this is why C is different. And then the rest of the book tells you everything you need to know in as few words as possible. And it's just wonderful. It was a pleasure to read. And I started programming.
So this was programming in C by using Unix?
No, that was probably on a PC.
Okay.
But it compiled, right? So they could run it wherever they wanted to. Yeah, and it was the really interesting thing was like 2 days before the thing had to go live, found that when I had a debug message at the very beginning, just to print a value, it was fine. But when I took that out, the program crashed.
Welcome to programming.
And I went to the guy I was reporting to, who was, he was a young kid, maybe late 20s, early 30s. And I said, well, what do I do? He said, well, just make it a print to a string and just don't do anything with the string. That's really clever. So I did that. And it was probably 35 years later where I was doing something totally unrelated. And I went, oh, that was a Stack Overflow. That buffer wasn't big enough.
Right.
So yeah, you never forget the big ones.
Yeah. I have a couple of bugs like that I still remember.
We all do, yeah.
Yeah.
So then I went to grad school. I went to Carnegie Mellon.
Nice.
Biomedical. It was the biomedical engineering department. My degree was in electrical engineering. And the project, I wanted to do a project because I was sick and tired of just studying things. And the labs at Rutgers were more analysis than actually discovering things. So this project was in lateralization of amplitude modulated noise and tones, I think, which basically
means in English.
A pair of headphones,
Uh-huh.
and you listen to a tone or some noise. How does your brain decide which side it's coming from, or where in your head is it?
Interesting.
So I built this system. The first thing I had to do was interface a genuine Intel 386 machine with an 8-bit parallel port to a 16-bit essentially volume control, so I could control that. And then I used C to generate these different waveforms, which was basically just sines and cosines and math. And for the first time, I could actually hear the things that I had learned about at Rutgers. And I understood what it meant to overmodulate something, or to clip, or to undersample, or all these other things that audio people know all about, and all I saw were waveforms. So that was really, really cool. I wrote serial code to talk to a VT100 terminal in a soundproof booth. And my subject would go into the soundproof booth, and I'd play the tone.
Mm-hmm.
And I basically had a line with a dot in the middle of it. And by using the arrow keys, they could move the dot left or right to indicate where, how far to the left or right they heard the tone.
Right.
The most important thing that I learned was that I never, ever, ever want to do experiments on humans again, because we are so unreliable. I played the same tone to the same person 2 different days.
Right.
One day she said it was all the way on the left. One day she said it was all the way on the right. And I said, do you have a cold, or did you have a cold? No. That's the way it sounds. And so the spoiler is that there are 2 ways that you can tell, right? If I'm standing to your left and I talk at you,
right,
then the sound is louder on your left than your right, because it's got to travel a little bit more. It also gets to your left ear just a little bit sooner than your right ear.
Right.
So those are 2 different cues. There's a time delay and there's a volume difference. So what we did for the experiment, everybody knows if it's louder on one side and it gets there first, that's where you hear it. But what if it's louder on one side, but it gets to the other side first? Well, it depends on the frequency.
Oh,
if it's a low frequency sound, then your head is enough of a wavelength wide that you can tell the difference in phase. If it's a high pitched sound, well, maybe you're 2 wavelengths different. And if it's exactly 2 wavelengths, you can't tell the difference because the waves line up.
Oh.
Yeah. So that was just fascinating. So that's what I learned about signal processing and speech and things like that.
So this is something they use in constructing stereos or some such, or research in general?
You know what they use it for? They use it for directional antennas.
Oh, right.
You have an array of microphones, say just a line of 5 microphones,
mm-hmm.
and you're just recording from all of them, you'll hear whatever straight ahead.
Right.
But if you delay them in series, so the one on the left is a little bit slower than the next one is slower than the next one, then you're actually focusing towards the left, because a sound that gets there from the left will now arrive at all of the microphones at the same time after those delays. And the magic there is that basically the worse the sound is to start with, the better the result is. And that's just magic to me. And I'm sure that there's got to be some limit, but I never got to actually ask that question.
So what did you do after Carnegie Mellon then?
So after grad school, I spent a year or so working in the biomedical engineering lab at Rutgers, using the signal processing that I learned for 2 things. Another student's PhD project had to do with measuring something about the body by recording blood pressure at several different places. And they needed to do some calculation and figure it out. And about a year or so into the program, they said, this just isn't working. Can you help me? And I looked at it and I said, your sampling rate's too low. You can't do this. It can't possibly work. And of course, they didn't believe me, so they kept trying and trying. And it kind of sort of almost worked, but it's like listening to AM radio going under a bridge, I guess. But the cool thing was that the professor I was working for also taught pulse systems, which was the only really practical class that I took. So it was a grad level class. I said, hey, can I audit that? He said, you can, but you already know this stuff. Like, yeah, but I can't sit in a room with you and not learn something. So yeah, fine, if you want to. So he gave them projects, things to do, like a heart rate monitor, which I did on. This was going to tell you the wrong computer, but it was maybe an 8-bit microprocessor with no memory.
Right.
So like we had to write the thing that tells the LCD display, right? How do you turn a segment on? And in order to do that, I figure it's like an LED. It's not. You have to raise and lower the voltage on the backplane. I don't know how many times a second. And then not do that on the segments that you want to light up or darken up. So we had to do that. We had to build the whole character generator. Like if I want to print a 2, what does a 2 look like? So we had to do everything. It was like going camping. It was wonderful. And by the time it got done, you could get your heart rate in beats per minute. You could get the time in seconds per beat. And if it was too fast, it would say fast. And if it was too slow, it said dead. And the professor loved that. And he said, why is it that you're the only person who's not actually taking my class and nobody else has actually done this project? Because it's fun, right? The reason I was there was to build an accelerometer. It was a metal box about the size of 3 or 4 cigarette carton, or 3 or 4 cigarette packs, but I hate that analogy. So I don't know, the size of a big portable disk drive or something. I don't know.
Right.
And the deal was they would bolt that onto a big shipping container when they were going to send cargo somewhere. Mm-hmm. And when it got there and it was damaged, they wanted to know when it happened, right? And in order to do that, it had to keep track of time. It had to keep track of essentially the jolts along the way. And there was no operating system. So we had to just start, I had to start from scratch. We had a NASA engineer solder the thing together because it was all surface mount stuff. And that was an 8051, I think, an Intel processor. And again,
what was the storage?
Oh, nothing. To the point that in order to store a quarter of a second's worth of data, I could not use integers. I had to use unsigned characters because I had to save bits, and an unsigned character back then was half as big as an integer.
Right.
But I didn't want to lose the resolution. So as I got the data that came in, I brought that in as floats, but then I scaled them so they would all fit from 0 to 255 and save them as integers. Maybe there's 4K memory or something in there. I don't remember. But what good is that unless you can get the data out? So again, I wrote the serial routine so you could plug that into a PC, and I wrote code there. We could download the data and graph it and everything. And the customer there was, it was a company in Germany, and I don't remember who they were, but they said, we need 3 measurements. We need to know the peak acceleration, the change in velocity, and the equivalent drop height. And I said, okay, well, the peak acceleration, I get that, right? Is that you look at the acceleration in all 3 directions and wherever it's biggest, right? You just say that. Change in velocity, you integrate all the accelerations. Right. And when you're done, it tells you which direction it would be moving in and how much faster or slower. I said, what's equivalent drop height? I'd never heard of that before. And they said, oh, well, we want you to tell us that the jolt, the shock was about the same as if you dropped it from however many meters. Okay. So I went back and, I coded the acceleration, I coded the velocity, and I'm scratching my head with the drop height. So for our next conference call, and back then, long distance was really expensive.
Yeah, right.
So, I did these 2 things, but for the equivalent drop height, you said that's as if I dropped it from a certain height. They said, yes. I said, onto what? And they said, what do you mean? I said, onto a pillow, onto some concrete. And they said, we will get back to you on this. And then the next week they said, we will not be needing this calculation. That was also the project that I discovered that the compiler could not multiply.
Oh, interesting.
When I had to do this scaling, it was almost always, whenever I did it, I would get 0. And that could possibly be, right? Usually I was converting from bigger values to smaller values. So I would multiply by, say, 0.8 or something like that. And the rules of C say if you're taking an integer and you're multiplying it by a float, like 0.8, you change the integer to a floating point number.
Right.
You do the operation, which gives you the floating point number, so you get the full precision. And then when you're done, you convert it back to an integer so you can store it.
Right.
So I narrowed this down to 3 lines of code, and I called them up over the phone. And I said, here, let me dictate this to you. I'm sure I'm doing something wrong, because never blame the compiler, right? It turns out that if I take any number and I multiply it by 0.8, I get 0 every single time. And they said, well, we'll look into it. We'll get back to you. And I figured, I'm a grad student. They're never going to get back to me. Well, sure enough, they called me back a couple days later. They said, oh, we're so sorry. You're right. Our compiler can't multiply. It turns out that if you use times equals, like if you took 5 and you times equals multiplied it by 0.8, it would demote the 0.8 to an integer, which is 0.
Right.
Do the multiplication, which is 0.
Yeah.
You convert it back to an integer, which is zero. And there you go. They said, well, the good news is the workaround is if you just say 5 times 8 instead of times equals, it'll work. And I said, good, because I really didn't want to have to write floating point multiplication myself. But I mean, those were the days where if that's what you had to do, you didn't think twice, you just did it.
So this was, you were still at Rutgers, or?
So this was after grad school, and I was working. People thought I was a grad student, and that was just fine with me.
Okay.
Then from there, I got my first real job, which was a company that I stayed at for 15 years, but not in a row, before Google, where we made network security appliances, like from scratch. Our hardware guy designed the boards. We did have a board support package, which meant that we could talk to the registers on the chips on the board, but we had to figure all the stuff out. My first job was to teach the engineers how to program in C because I had been programming it on a Z8 processor and assembly language. And that was really funny because at one point, my boss, who was a co-founder and a longtime mentor and friend now, said to me, well, but how do I jump into this routine at different places if I want to start doing different? I'm like, what are you talking about? Like, if it's a C function, you call the function and then you leave. And I knew he was trying to program assembly language in C.
Right.
And once I realized where he was coming from, the rest was easy, right? The hard part is figuring out what's difficult.
Right.
So this thing had built in, it had 4 serial ports, 2 modem ports, a console port, and an Ethernet connector. That was the next generation was Ethernet, before anybody knew what Ethernet was. And we basically could talk to anything. Their first use was for the telephone company because twice a year on daylight savings starts and ends, they would have to roll a truck out to every premises and set the clock in their phone switch an hour ahead. Right? And my founders had the brilliant idea that, hey, we can do this automatically for you because everything talks through a serial port. So we did that. And then we realized, well, but these phone switches also send stuff out. Like they print out every time a call is dialed.
Right.
And one company said, it'd be really cool if we could get an alert if anybody ever dials 911. So we had to do that. And then we said, well, as long as we're there, we can do maintenance on this. So why don't we have some automated routines that do that? And the next thing you know, we had this whole package that could be custom programmable. We had classes and taught customers how to program them. And almost without fail, they all said, okay, this is really cool, but will you do it for us? So they paid us to write the code. The version that it evolved into had expansion boards, so we could add up to 24 more serial ports.
What processor was this?
This was an NC3 68360 Motorola.
Yeah. Actually, that was a nice machine. Yeah.
Yeah, it was the 68,000 series, right? So it was like the original Mac, I think.
The original Mac. Yeah.
It was a joy to program because it didn't have any of this weird memory mapping stuff that Intel, I think, does.
Right.
And the registers were just there and you could poke values into them and they would do stuff. And it was just, it all made sense. And being an old modem guy, I already knew how to talk modem and which registers did what. Along the way, I became the cable guy because if you had to take our thing, which had a normal serial connector, and plug that into a Cisco something or other that has Cisco's own proprietary or whatever, well, how do you wire that up? I don't know. Ask Adam. So I learned how to do all that. At one point, I got tired of it. So I taught every single person in the company during lunch how to build a serial cable with materials. And everybody built one. We had the testers and everybody tested them and they all worked. And from then on, I built all the serial cables because nobody else wanted to. But this is just a really, really neat machine. It did. It was so far ahead of its time. You could have it dial another machine, and they would authenticate to each other. You could call it. You would give it your username and password, and then it would drop the phone and call you back. So
Okay.
you didn't have to pay for the long distance.
I wonder if we used those because many years ago, when I worked at the bank, we had some kind of a setup so you could, you know, do support in the middle of the night or weekend or something, and it was this kind of a system where we would call it on the phone, and then would call us back.
So the original one that worked in assembly language was called the IPC, Intelligent Port Controller.
Hmm.
And then the newer version became the Sentinel 2000, which we
Hmm.
call S2K. So that gives you an idea of when we were doing this.
Right.
Um, a couple neat things along the way. At one point during a class, we were talking. The instructor, the other co-founder, was teaching them. Well, let's start by turning the LEDs on and off. Right. So if you have 4 ports and 2 modems, and they all have LEDs that tell you whether they're on and whether they're transmitting, and all those LEDs are controlled by software. Well, let's learn how to turn the LEDs on and off. So we did that. And he said, all right, so let's do something more fun. We have random number generators, and we also have encryption routines.
Mhm.
Let's see if we can turn them on and off randomly, which raised the question, well, what's random?
Right.
So one person said, well, if they all go on and off about the same number of times each, that's random. And I said, well, but if the first one goes off on and off 10 times, and then the next one does, and the next, that's not random.
Right.
And I said, there's actually a function, and yay, I got to use something I learned in grad school called an autocorrelation, which basically tells you if you keep track of all this stuff, and then you duplicate that and you shift it. So you're looking at the reading now and comparing that to the reading, say, a minute ago.
Mhm.
And you do that through the whole thing. If it's really random, the average should be like 0 because they should not at all be related to each other.
Right.
And if they are, then you know that there's something similar between them.
Right.
So Mike says to me, well, we have this encryption routine, and theoretically, if we take our random number and we encrypt it, it's supposed to be more random.
Right.
And
Exactly.
I don't know what that means. And can you figure that out? I said, let's give it a shot. So I went and I wrote the code to do that, and I printed it out. And the regular random number thing, it looked like a wavy line, like you would expect. The encrypted one, the wavy line was much, much, much lower, which meant that the two signals were not as correlated, so it was more random. But there was a huge spike at one point, right in the middle.
Mm.
Mike says, what's that? I said, that's a bug in the encryption routine. I said, really? Where? I said, I don't know, but I'll find out. And sure enough, I came back after lunch and I had found that there was a variable that had not been initialized. It could have had 255 different values because it was a single byte.
Right.
And he said, so what would have been the effect of that? I said, well, I guess like one time out of 255, you'd log in correctly and it would fail. And he said, that's happened to me exactly twice. I said, that's great. It won't happen again. So it's really rewarding. And I think I told my folks so they knew that the money that we spent on grad school might have done with it. And we just had all kinds of escapades there because it was a small company. We could just do stuff. And we just had so much fun. I left at about 2000 because one of the founders also left to start another company. Mm-hmm. That was called Outer Curve because we worked on rims from Research in Motion. They became the BlackBerry company. Right. And I am ashamed to admit that the founder had to tell me that rim was, or that Outer Curve was a pun on rim. I'm like, oh, look at that. What do you know? We built the first over-the-air programmable device. The way things worked back then was that you would have this two-way pager, and that was the one that had the keypad, right? But it was a tiny little thing. You had to plug it into a cradle that was plugged into your computer if you wanted to load software onto it. We had all come from this company where we had these programs that we wrote, and they were all interpreted by the operating system, the box that we built, mm-hmm. which meant they were just data. And well, two-way pagers can send and receive data.
Right.
So we wrote essentially a shell that was interpreter. And our apps were just written in like bytecode. We would write them, and if you wanted to download them, we would send them as data, and then your device would see them and run them.
Nice.
And it was great. So our company, our real customers were Wall Street, because what do you need right here, right now? Back then, real-time stock quotes.
Right.
But we figured we wouldn't sell too many of them if that's all we did. So we put together this suite of applications called Portable World. And that consisted of whatever the engineers felt like doing. So somebody had like a how do I mix a drink app. I was able to use a website back then before anything was locked down, where you could give it an address and it would look it up and give you the name of the person and the phone number and everything. You can give it the first N digits of a phone number and it would give you all the ones that matched, which is really kind of neat.
This is running on the BlackBerry?
A RIM. So like a baby BlackBerry. Yeah.
Okay.
The screen was, I don't know, maybe it was like 16 characters by 4 characters or so.
Yeah. I remember having beepers, which just had like one line.
Yeah, this is
a little bit beyond that. Yeah.
Yeah. One guy used to work at Bell South, and they were our service provider. So he knew, like, we could use the device to ask it, what cell tower am I connected to? And it would say, I don't know, 235Q6.
Right.
But he knew how to decode that because he worked for the company that made the towers. So I wrote the Where's My Wife at? Which was cool. And she had the Where's My Husband app. And it was great because it meant that, I could have dinner ready when she got home. What else right. So the most fun that I had with this was when I realized that the X10 remote control system, which was this antique thing that you could buy at Radio Shack, you would take a gizmo and plug it into an outlet, and you'd plug a lamp into it. And then you had another remote control that you plug into another outlet. And as you push the buttons, you could turn the other outlets on and off. So that was really neat. They also sold a thing that would convert serial data to whatever it spoke. I'm like, well, I've spent my life doing serial stuff. That sounds cool. And I happened to have one of the devices from the old company at home because they're like, well, if we ever need you to help, you need to have one of these. I'm, okay, fine. So I programmed it to translate to speak that. But this thing also could be on the internet. So I wrote an app where from my RIM, I could pick a device in my house and it would send the request to our backend server.
Right.
I would look it up and say, oh, that's app number 62. What's that? Oh, right. In order to work that app, we have to contact this IP or this website, which was the computer in my house. Right. And my computer in the house would answer it, and then it would send it down to the Sentinel 2000 that would talk to the Radio Shack thing and turn the lights on and off. And I just thought that was the coolest thing until at that point, our eldest was an infant, and the neighbor diagonally across from us had a spotlight that would shine right into the bedroom, right into the crib, and it drove me nuts until I discovered that we were on the same power transformer as they were. So I could turn their light on and off. And apparently they never found out because when they left, when they were moving out, and my wife loves real estate and houses and stuff, she wanted to go look at the house. And she said, by the way, did you notice that sometimes your backlight would turn off at random? I said, yeah. She said, well, it used to shine into our infant's crib. So my husband turned, she's like, that was you. So, yeah. So, yeah, see, the more you know, the more fun you can have, right?
It's all about the fun. So how did you wind up at Google eventually?
Well, so when Outer Curve went bankrupt, the joke is you get in at chapter 1, you get out before chapter 11. I went to a company that, again, made serial consoles that you would connect to any number of keyboard mouse things and any number of computers, and any keyboard could control any computer. So it was what we now think of as a KVM, keyboard video mouse switch. But they theirs were cascadable. So in theory, you could have, say, 64 computers controlling 2048 or keyboards controlling 2048 computers. And they hired me because they had no clue how to test it.
Oh.
And I said, well, you take one of your devices and you spray paint it orange, and now it's not one of your devices, it's a testing tool. Mm-hmm. And you write code to have it test the other ones. That's a great idea. So we never got to test it because the team before me tried for like a year to get this thing working, and it didn't. And again, since I had just come from a bunch of jobs where we did serial things, I'm like, I know how to do this. So we started from scratch. I had a team of maybe 4 people, and they were young and they weren't terribly experienced, but they were bright and they were dedicated. And I made sure to let them know that I knew it. We got that thing out the door in 4 months from scratch. And as far as I know, they never came back. So that was a really cool thing. And then what did I do after that? There might have been something else, but then I ended up back at the security company again for a while. Things did not go well there. And a friend of mine, you may know Rob Konigsberg, and you should interview him. He called me at one point, and we were just chatting. We had worked together in 1990 or something, and this is already, a decade or more later.
Right.
And he says, hey, Adam, guess what I found in my basement? I said, I don't know, 4 inches of standing water, because we had just had hurricanes. It's like, no, I found the coding standards that you wrote when we were at this other company. And I said, why do you have them? He said, well, because I really liked them. They were good and they were helpful. Can I bring them to work? And I said, well, they're not proprietary. I got permission to take them before I left. But is this like a coding tool, or is this a resume? And he said, what are you talking about? I said, Rob, you work at Google. He said, oh, yeah, right. You should apply. So after they completely ignored me for my first application, once I had the referral, that's the magic. And I fooled them. Apparently, I fooled them for 14 years.
What did you do at Google?
I did a bunch of things. My first gig was in Corpeng, which was, I think David talked about that as well. It was a group that built tools that were used inside Google. And we were going to build a tool for the legal team to use to keep track of all of their cases, because apparently way back then they used spreadsheets because everybody used spreadsheets.
Right.
P.S. The way that you would reserve a conference room back then was you would walk over to the room, you get a pen, and you would write your name and the time on the sheet of paper that was taped to the door every day. So we've come a very long way since then.
Yeah.
So we wrote this legal app, and again, worked on it for I don't know how long. I learned Java. My mentor was just an incredible Java expert. I think he was a level 5 when I left, and when I started, and I don't know if he's 7 or 8 now. He's a brilliant guy and a really good teacher. We got along well. And just before we were about to release it, the VP from California flew out to thank us and tell us that they were canceling it and going with an outside vendor. So that was why my first attempt at promotion failed, because there was no impact. They said, no, the story is great. It's difficult. It touches all the things, but there's no impact. Don't have control over it. And that's the way things work. So, okay.
Yeah.
So from there, I moved to Build Tools team, which is, I said, it's the team that builds the tools Google uses to build Google. I worked specifically on the file system that keeps track of the bits and pieces of your compiled code.
Right.
Because, if you have 2 developers, fine, you each develop on your own computer, right? But if you have, I don't know, back then, maybe 20,000 developers, if I just built something and you need to build the same thing, why should you build it again? Just take what I did.
Right, exactly.
So this was a system that would very efficiently figure out how to take these pieces and break them into chunks and store them and index them and then duplicate them around the world. So if you needed to do a thing, it would find the data center closest to you and give you the piece so you wouldn't have to build it yourself.
Right.
So yeah, my claim to fame there was when we had to automate data center drains. If a data center is going to go down for maintenance, you basically have to stop everything from running in it. You can't just turn it off, right? You have to wait until each thing finishes. And it was a big manual process, and it was a pain in the neck, and it was very labor intensive. And they said, we should just be able to automate this. I'm like, okay. So that was my job. And we did it. We tested it in New York. The way Google rolls things out is that they try it a little bit, then they try it in a data center, then they try it in a couple data centers. And then I think we probably rolled it out to the whole US. Mm-hmm. And at 5 o'clock on a Friday, the senior guy on my team says, looks like it works. Push it. You do not push code at 5 o'clock on a Friday before a holiday weekend. Come on, we tested it. We know it works. It's fine. What's the worst that could happen? Well, fast forward to the next Take Your Child to Work day, when my kids are sitting in GWB Tech Talk. All of the rooms in New York in Google are named after New York places like George Washington Bridge. And this was the biggest, at that point, the biggest conference room we had. And the Googler who was presenting, asked, so do any of you know what your parents do at Google? And my kid raises their hand and waves it wildly like there was no tomorrow. And what does your dad do? And my eldest, who I love dearly, says, my daddy took down Europe. And all of the spouses who were there went, and all of the Googlers who were there went, yep, been there.
Excellent.
Luckily at Google, we have one button rollbacks. So we didn't do any damage. Europe was asleep by then. And nobody was the wiser but my kids and me. So from there, that's when I moved to EngProd, which was wonderful.
What was EngProd actually?
Yeah, so EngProd stands for Engineering Productivity. Mm-hmm. And we did whatever had to be done to make engineers happier. That could mean speed up their work. It could mean make their work easier to do. It could mean automating stuff. It could mean testing things. We were not test engineers. We had there was a separate title for a test engineer, but we would build the testing systems. Mm-hmm. Right, that the test engineers could say, okay, well, now that we have this system, these are the different types of tests that we should run on it. So I started out on the Batmobile team, which tested the Google core that ran on Android and the Google stuff that ran on iPhones. Batmobile stood for Batmobile as Android testing on mobile.
Oh, I see.
That was kind of neat. Maybe it was ads testing because we were part of ads at that point. And I stayed there for years and years and years and years until a new manager said to me, hey, this project over here does video and you do video and they need a new tech lead because the old one's moving to Tennessee. You got to go there. And I'm like, oh, but I like this team. No, got to go there. Okay, fine. So that was the last team that I was on. By the way, that real team was still so close knit. We still have breakfast periodically together. They're like family. Just it was the best team I have ever been on, probably ever. Just good people and really bright, to the point where everybody talks about imposter syndrome, and we would think nothing about just turning around and saying, okay, somebody come over here and tell me why I'm being stupid. And nobody had to prove anything, and everybody respected each other because we all helped each other, and it was what a team is supposed to be. It's great. So the video team, the last thing that I did was I ran a lab that tested set-top boxes, which are things like the Google TV box. It's hardware, Google TV box, or Apple TV, or Roku, or any of these other things. We had to make sure that we could play ads on them because that's what ads does. And if the thing crashes when you come back from an ad to the main program, then like CBS gets really mad at you. So we had to test all this stuff. And the very first thing that I did there was automate that lab, because I said I am not climbing up and down all those flights of stairs every time something needs to be fixed or rebooted. So I spent a long time doing all that, built it up, got it working, got it to the point where we replicated it in California. P.S. I have never traveled for Google. I'm probably the only Googler who'd never been to the mothership.
Oh, interesting.
So we got them to set up and maintain and run that lab remotely. mostly as a proof of concept to prove that it could be done. And they were great. And then we were talking about doing another lab that never quite got off the ground just because things take a long time to happen for all the approvals and acquisitions and things like that. But then COVID hit, and it was great because I could continue to run the labs remotely and I never had to go into the office. Once in a while, I would have a teammate go down there and like check something for me or whatever. But the rest is remote. I had a lab here on my desk in case. And it was just, it was really, really fun. I'm not sure what else I can say about that.
So did you get to use any of the AI tools when you were there, or did that come up at all?
AI had just started to become a thing. They had a thing called Ducky,
right,
which I think is now the tool that developers use when they build Google code.
Yeah, it's really like internal ChatGPT kind of thing.
Yeah. When I started, it started out by looking for invariants. So if you're processing all this data, like all this ad data, right? And there should be an invariant. Like if this bit is set, then this ad should never be sent to children under whatever 13. And it could look at all the logs and make sure that was actually the case.
Mm-hmm.
So if you do that and then you multiply it by thousands, right? And it would just do all the stuff and give you a report and tell you if you were in spec or out of spec. But no, that was really the bulk of AI at that point. Got way more exciting after I left.
So that's great. So let me ask you my last question is, if you were advising somebody who's entering the field now, obviously the thing you would say is you have to have fun, but what would your advice be?
Yeah, definitely. If you're not enthusiastic about it, I hated interviewing candidates. And I say, so, what kind of code do you write for fun? I'm like, this is my job. I don't write code for fun. Like, okay, you probably won't be you'll do fine, but you won't be a stellar engineer. In any pretty much, in any type of job, if you love what you're doing, it makes a difference because it's easier to be good at it because you'll keep trying. So yeah, definitely love what you're doing. Do not rely on AI, because if you do, you will never learn how to do the things. And if you don't make the mistakes, you won't have the knowledge, and you won't be able, when somebody says, how did you know that? To say, well, because I already made that mistake 6 times.
Right.
Right. That's really the best way to learn. I would agree that you should go very deep on something, whether that be an architecture or a language or both, but then also become a generalist, because at Google, one of the interesting things is the last question that you ask if you switch teams is, oh, by the way, what languages do you code in? Because once you know enough programming languages, they're all the same. You just have to figure out how to ask it what to do. Learning a new coding language should not be a barrier.
Right, I agree.
Right. So maybe learn how to abstract, right? What are the things that languages need to be able to do? And how does this language do that? Right. What are the features that set this one apart from the other ones? Because people will say, well, which is better, Python or Java? Well, I don't know. What are you trying to do?
Right.
It all depends. Invest in yourself. See if you can, if you're working on any kind of hardware, see if you can bring some home, and just do stuff with it. Because again, you'll make the mistakes, you'll really find out what goes on inside. And that's really valuable. And it's the kind of thing that AI, at least now, doesn't know how to do. It doesn't know how to take two apparently disparate things and say, oh, wait, you're building a chip that models neurons in the brain, and that looks just like the algorithms that Claude Shannon wrote on information theory. Maybe we can apply those two things together.
Right.
Right. It's the serendipity. It's the human touch. I swear I got the job at Google because of social engineering. When I say, yeah, I fooled them. I tell people when you interview, your job is to make the interviewer want to work with you.
Right.
Right. So I would always start with a joke and see how they reacted. And if they were cold, I didn't do that again. Right. If they came back with a better one, then great. Now we know what we're doing.
I did the reverse thing. Like at some other jobs, when I was interviewing, I would tell people a joke, and if they did not laugh, then they get negative points.
Look, yeah, but I was the interviewee, so I didn't have that luxury. What else did I do? Ask lots of questions. Don't be afraid to ask, because you will sit there. We tell our interns, we will allow you to sit and bang your head against your computer for an hour. And after that, come and ask us. We want you to ask us. We don't want you to waste your time, because it doesn't do anybody any good.
Right.
Maybe be nice and save up your questions and go barrage somebody with them once during the day, as opposed to every 10 minutes. But when you need help, get help, and trust people over AI.
Right. Well, that was the nice thing about Google, right? Everybody was always very helpful.
Yeah, what I found is that nobody had time for anything, but if you stop somebody and said, hey, can you help me? I don't know if anybody ever said no to me.
Right.
And I'm not cute or anything, so.
All right. Very cool. This was very interesting. We almost had an hour, so let's wrap it up.
Yes, it's fun. It's fun to reminisce with people you don't know.
Thank you so much. And to our listeners, hope you enjoyed this conversation, and come back next time.
Thanks, Richie.
Thank you.